Hello, and I'm about to show you guys the Batman Oscillation. So, starting off, we have mostly a basic sine wave. It's a little bit different in the sense that the position of the wave is being raised to the y power, which works out because anything between -1 and 1 will become a number between 0 and 1, which is, it means it has a range. It doesn't become infinitely large, like, 2 to the something power would just completely clip your speakers, but between -1 and 1 is cool for this. It's raised to the 4. I'm not exactly sure of the math behind it, but I'm pretty sure it has something to do with the way that I both doubled the height, because sine squared, if you don't know, looks pretty much exactly the same as sine, except for the phase is half the length, and it's all above the y-axis between 0 and 1. Basically, though, it's the same thing. So if you have the x coming in, basically that'll double the phase, and then double the height and subtract 1, and you'll have it centered, and it's right on cue. So something having to do with those numbers is making it so it has to be raised to the 4th power to be a normal sine wave. I would think it'd be raised to the 1, but I'll have to look into it. Anyways, this is just the basic setup, and then next it goes to modulus. So what I have it doing right now is any number, or it's just modulus, just plain old modulus. So it's the remainder after you divide whatever this is. So apparently the wave is actually oscillating between, let's see, oh sorry, all dry, we need the wet. The wave is oscillating between 0.21 and -2.1, because until then modulus doesn't make a difference. So I guess before I do this, I should round the head up for our Batman. There we go, we got a nice domey looking head there. And then I'm gonna try and add a couple ears. You see I go all the way. Basically, however many times 0.21 is divisible by something, by, I don't know, this is how many extra little peaks you get there. But we just want this, we're just kind of messing around. And then add a little bit of dry to up a bit, maybe tweak this. There we go, and there's the Batman Oscillation. Sine raised to the 1.5, or 2 sine raised to the 1.5, all quantity times 2, and then subtract 1, modulus 0.157, and then multiply that by take the original signal, multiply it by 0.88, and then add it to that, and you will get this Batman head. So maybe I'll have to write that up and show it. I might forget. But if you want that oscillation, there it is. And I think it's really cool. I think it sounds kind of cool. And also, you can do this, which I think sounds really nice. Also, I have another form of modulus right here, this next one. It basically, anything that would be the remainder is subtracted from the signal, breaking it into little pieces. So right here, what would be the remainder of modulus 0.015 at that point is subtracted from it. So it breaks it into little steps. I called it Y bricks. And between the two of these, let me put my headphones on, you get some really cool stuff. here's my ventures with Modulous. I think it's really cool just listening to what it does. It's not exactly maintained, I'm not sure what to say, tuned, I guess I should say, mathematically, and I don't know exactly what I would have to do to get it truly tuned. I mean, specifically with something like this one, due to something like this, due to the fact that this is the frequency you're going to hear, this width, so it doesn't really matter the height. That makes no difference. That's dynamic range in a sense, and the width is what you're really tuning. So it's always going to be just low frequency, high frequency, higher frequency, lower, lower. You know, it's I can't imagine what mathematics it would take to make those all relative to each other in a clear and ordered way. But anyways, that's how you make the Batman oscillation. Thanks for watching.